In this lecture, we are going to talk about deep neural network and the intuition behind it, right? So first of all, let's understand what does the term deep neural network means. So in general, if you'll take a look at AI, which stands for artificial intelligence, let's assume this is a circle. AI, which stands for artificial intelligence, it is a branch of computer science that deals with uh, machines, right? So, so any machine activity, like let's say a robot which is used by vacuum cleaner, a robot that is used in the kitchen to do some cleanups, is a part of artificial intelligence, where machines are doing the human-like work. Now, machine learning is a subset of AI, where you basically take data which is generated by human beings and train a machine to mimic the human behavior, right? So here in this particular case, we use several machine learning algorithms like support vector machines, linear regression, logistic regression, ensemble algorithm. To teach a machine, you feed the machine to a data, and that machine will learn from the data. It will decipher the rules, and then when you feed the new data, uh, it will try to predict what the output look like. So the difference between AI and ML is AI may or may not involve ML. There are a lot of ML, not ML tasks involved in AI. Just like, for example, a vacuum cleaner, which doesn't require any intelligence. It just always follow the same instructions given a specific directions. It doesn't require any ML, but there are few smart devices where we need to feed ML data and they train from it. So AI may or may not involve any ML, right? That's the difference. And again, subset of ML is nothing but a deep learning. It's also known as the deep neural network. So deep neural network is a special branch of ML where we use artificial neural network to learn from the data and predict from the data. So artificial neural network is a general specific branch of ML where we specifically use, instead of using a special algorithm like support vector machine ensemble, we use a common algorithm which is mainly based on a neural network. And when you say deep, neural network has multiple layers. A deep neural network is a neural network which has more than 4 layers, and we'll learn about that more. Okay, so it's very important to understand the difference between AI, ML, and DL. People often use it interchangeably, but when you are learning more about AI, ML, and deep learning, it's very important to understand the difference between these three. So AI is a general branch of computer science that deals with machine. It may or may not involve training the machine. It may involve doing a dumb task, right, by a machine, but it's mainly about machine doing the human task. Machine learning is adding intelligence where you train a machine to do a certain task based on the historical data. And deep learning is a special branch of machine learning where we heavily use artificial neural networks to solve a machine learning problem. Typically, you know that in any algebra, if you have a line like this can be represented as y is equal to mx plus b, where m is the slope of the line, right? Dy by dx, and b is this y-intercept, right? So what we do is, in a machine learning problem, let's say you have x and y and you have several points that you want to predict like this. What we do is essentially we draw a line which we use based on this data that we have. We feed that to machine learning algorithm, and the machine learning algorithm learns to predict this line, which approximately mimics the behavior of this where the training data lies, right? So that process, so this is, let's say output is y hat. So this is what machine learning algorithm learns to predict, and the way it learns to predict accurately is, so let's say y hat is the predicted output, y is the actual output, it calculates the error between y hat minus y, and it tries to minimize the error, and during this process it learns new m and new b, which is this one and this one, and it keeps making y closer to y hat. This is what is machine learning all about, okay, simply put it. Now this is about linear regression. Let's say in case of logistic regression, so linear regression is applied where output is continuous variable, let's say real estate price or stock price, where the output is continuously variable, which has a value of, let's say $1,000, $200, something like that. So with the logistic regression, the main issue is about classification, right? So for instance, let's say you have data points, let's say, which talks about whether a tumor is malignant or cancerous based on length of the tumor. So this is length, and let's say this is the diagnosis, and let's say we have few points like this. Right? So logistic regression is all about predicting a line that differentiates between these 2 points. So we say anything that is on the right side of this line we can classify as malignant, and anything on the left at the same time is called as a benign, right? So logistic regression is mainly just classification. So here the equation is y is equal to same as mx plus b, but we also pass it through a function called activation function. So activation function, what it does, it gives me a probability values that is between 0 to 1. So anytime we say the value is greater than 0.5, we can classify it to be malignant, or anytime value is less than 0.5, we can classify it as a benign. Okay, so logistic regression is same as linear regression, but with the addition of an activation function. Okay, and the output is generally a probability instead of the actual values. Okay, we will learn more about what is actual activation function is used. So far what you have seen is y is equal to mx plus b, and the activation function we pass it to get the actual output, right? Okay, so this is basically represented, the activation function is generally sigmoid type. So this is, let's say f of z, it is represented as 1 plus e raised to minus z, and it looks something like this. So this is f of z, 0.5, 0, and this is z. Okay, so basically the sigmoid function is used to squish the output of a normal equation, which is mx plus b, because this output can go in any range, let's say between minus infinity to plus infinity, right? But this activation function, as you can see, it restricts the, as z tends to be a very large value, infinity, the f of z tends to be 1. Also if z tends to minus infinity, f of z tends to be minus 1. So it basically restricts, it tends to be 0. So it basically restricts, uh, squishes the value of output variable between 0 to 1, and this can be represented as probability, right, of output. And we say when the probability is 0.5, we can say the predicted output is 1, and when the probability is less than 0.5, we can say the probability is 0. That's how the logistic regression is used. So logistic regression is nothing but summation plus activation. Okay, so where summation is mx plus b, and then activation is this. So this is logistic regression. So in this example we saw a sigmoid function, but there are several other logistic regression functions that are used, which are called tanh, ReLU, and things like that. We don't have to worry about it right now. We just enough to understand the intuition behind it. So far what you have seen is y is equal to mx plus b, and the activation function we pass it to get the actual output, right? Okay, so this is basically represented. The activation function is generally sigmoid type. So this is, let's say f of z, it is represented as 1 plus e raised to minus z, and it looks something like this. So this is f of z, 0.5, 0, and this is z. Okay, so basically the sigmoid function is used to squish the output of a normal equation, which is mx plus b, because this output can go in any range, let's say between minus infinity to plus infinity, right? But this activation function, as you can see, it restricts the, as z tends to be a very large value, infinity, the f of z tends to be 1. Also if z tends to minus infinity, f of z tends to be minus 1. So it basically restricts, it tends to be 0. So it basically restricts, squishes the value of output variable between 0 to 1, and this can be represented as probability, right, of output. And we say when the probability is 0.5, we can say the predicted output is 1, and when the probability is less than 0.5, we can say the probability is 0. That's how the logistic regression is used. So logistic regression is nothing but summation plus activation. Okay, so where summation is mx plus b, and then activation is this. So this is logistic regression. So in this example we saw a sigmoid function, but there are several other logistic regression functions that are used, which are called tanh, ReLU, and things like that. We don't have to worry about it right now. We just enough to understand the intuition behind it. So in case of deep neural network, we have hierarchy of perceptrons. Okay, because a single perceptron just is a linear function, right? What if you have classification which does like this? So you have values like this. So there may not be a linear line that you can draw, right? In this case, to separate these 2 points, right? Let's say like this. So you have to have a boundary like this, right? So which is a non-linear. So to draw a non-linear boundary, you often need to club together multiple perceptrons. So the way to do that is this is input. So you draw one perceptron here, right? And then you draw another perceptron here, and then you can create another neural network here. Okay, You can draw one more. So uh, another one here, and then the final output, right? So this is X input, this is one hidden layer, this is another hidden layer. So this is called L1, L2. So here maybe we can say this. So the way to think about this is this. So let's say this line over here can be drawn like this, right? So I'm doing the same thing. This line can be thought of as combination of two lines, one that goes like this and the other one that goes like this, right? So you can assume that this network here is finding this linear line here, and this perceptron here is finding this linear here line here, and these two are then combined together to produce a final output that looks like this over here and over here too, right? So this multiple layers, hidden layers, can be combined to produce an output, and this is called a neural network. Now a deep this so these are called hidden layers. There are two hidden layers here. This is the input layer, and this is the output layer, right? So this is called a neural network, and anything which has more than four hidden layers is called a deep neural network. Greater than four hidden layers, and anything that has less than four hidden layers is called a shallow neural network. Okay, so that's what the deep neural network is used, and it is really good for finding the nonlinear boundaries in classification problem, and it is so popular that it can be generalized uh, to compute the solution for any problem. It's a generic algorithm. Okay, these are the weights that we talked about earlier, and these weights will vary at each layer: W1, 2 dash, double dash. And the neural network basically what it does is, first it computes the forward propagation, where it computes the output this as W1x plus b. So this we can put b also where there is no input, right? Then this also computes W1x plus b. Then it runs through an activation function, and it just passes through the next output. Then it computes the predicted output, right? Once it computes the predicted output, what it does, it tries to find the difference between predicted output and the actual output, right? It computes the error, right? And then it does something called a back propagation, where it propagates the way backwards all the weights, right, in this error, and it recomputes these weights W1, W2, and the bias, so that this error is reduces. Okay, and that is called a back propagation. So it is also known as back propagation, right? So this is known, this process of computing the output is known as the forward propagation, and then the process of updating the weights at each location and recomputing the output. So process of computing the weights by taking this error is called back propagation. Okay, so the process of forward propagation, backward propagation are combined to ensure that the error is minimized between the actual output and the predicted output. That's what deep neural network is all about.